Welcome to The Explainer. You know, there's this powerful idea that's quietly running in the background of your daily life, in everything from your email inbox to the most advanced AI. We're talking about Bayes' theorem.
So let's start with something we all get. An email pops up, and the subject line just screams, "win." Immediately your gut kicks in. Spam, right? But how does a machine, like your spam filter, get that same gut feeling using nothing but data?
Well, the answer comes down to this really elegant idea called Bayes' theorem. And at its heart, it's not just a formula. It's basically a recipe for learning from experience. It gives us a formal way to update what we believe when we get new information.
And hey, don't picture some dusty old formula from a textbook. Think of it more like an engine. The engine that gives AI a really critical, almost human ability. The power to reason, to make predictions, and maybe most importantly, to change its mind when it sees new facts.
So how does this belief engine actually work? Well, it all breaks down into 4 key ingredients. And don't worry about the technical names you're going to see. The ideas themselves are surprisingly straightforward.
Okay, so this table lays it all out perfectly. We always start with a prior. That's just our initial guess. Then we get a new clue, and we have to ask 2 things. First, what's the likelihood this clue shows up in the thing we're looking for? And second, how common is this clue in general? That's the evidence. You put all that together, and out comes our posterior, a new, smarter, updated belief. Let's actually see how this works with some numbers.
All right, enough with the theory. Let's put this thing to the test. And we're going to use a perfect real-world example, one that probably saved you a few headaches already today, the good old email spam filter.
We're going to follow a simple 3-step process, and it's going to mirror that table we just looked at. First, we state our initial belief, our prior. Then, we weigh the evidence. And finally, we'll calculate our new, updated posterior belief to see if that email is really spam. Okay, first things first, our starting point, our prior belief. Let's just say that, based on tons of past data, our system knows that about 20% of all emails flying around are spam. This is our baseline, our starting assumption, before we even look at a single word. Next, the likelihood. Now, our data shows us that the word win is a huge red flag. In fact, it shows up in 60% of all spam emails. So that's a pretty strong clue that we might be dealing with spam here. But, and this part is really important, the word win doesn't only appear in spam, right? Your friend could email you about a big win in their favorite video game. So, to figure out the total evidence, we also need to know how often win appears in perfectly legitimate emails. Let's say that happens about 10% of the time. So now we can calculate the total evidence. What are the odds of seeing the word win in any random email, good or bad? Well, as you can see, we take that 60% chance it's in spam and multiply it by the 20% of emails that are spam. Then we add the 10% chance it's in a good email, multiplied by the 80% of emails that are good. Add those 2 bits together, and we find out the word win appears in 20% of all emails, period. And now we're at the final step, calculating our new belief. We just plug everything into the formula. We take that 60% chance that win appears in spam, multiply it by our initial 20% belief that any email is spam, and then we divide that whole thing by the 20% chance of seeing the word win that we just figured out. And there you have it. The answer is 0.6, or 60%. That's our new, updated posterior belief. The probability that this specific email is spam, now that we know it has the word win, has jumped all the way to 60%. Just look at that jump. We started with a pretty vague 20% suspicion, but after looking at just one single piece of evidence, that one word, our confidence that this email is spam tripled to 60%. This right here, this is what it looks like when a machine learns. And you know, this powerful way of updating beliefs isn't just for sorting your junk mail. It's really the foundational reasoning engine that lets all kinds of AI systems make smart decisions in a world that's filled with uncertainty. I mean, think about fields where the stakes are incredibly high, like medicine or security. This is how an AI can look at a bunch of symptoms and calculate the most probable diagnosis. It's how it can sift through oceans of network data to spot that one tiny anomaly that could signal a huge cyber attack.
And you interact with this logic all the time, every single day. It's the reason why your streaming service knows exactly what you want to watch next. It's how a search engine can figure out what you really mean by your search terms. It's the invisible engine of personalization.
And at the real cutting edge of AI, this is absolutely essential. It allows a robot to take conflicting data from, say, a camera and a laser sensor and fuse it all together into one coherent understanding of the world. It's the very mechanism that lets machine learning models get smarter with every new piece of data they see.
So what's the big idea here? Why does this one theorem from a long time ago matter so much for the future of AI?
You know, the true power of Bayes' theorem is that it gives machines a rigorous mathematical way to deal with all the gray areas in the real world. It lets them move beyond a simple yes or no and start thinking in terms of probably and unlikely, a lot like we do.
Really, at the end of the day, it's a framework for reasoning, for learning, and for making the most intelligent guess you can with the evidence you have. And that is absolutely essential if you want to build systems that can truly think and adapt.
And that leads us with one final, and I think really crucial question. If AI learns by updating its beliefs from the data we feed it, then we have to ask ourselves, what are the most important beliefs we are teaching it right now?